Good afternoon, everyone. My name is Christy Ford. I'm the account executive at Online Resources and your moderator for today. A quick reminder, please turn on your full screen mode for better viewing of the presentations. And if you have any questions, go ahead and type those in as we go, and we'll get to those either throughout the presentation or at the end. We would like to welcome everyone to our deeper dive with QPoint Robotic Solutions. They're here today with us to showcase their inline automated system, and this is managed with their lean interface. So we're looking forward to seeing that. We've been strategic partners with QPoint since 2013, and we are excited to have them here with us. Let's jump right in. Here with us from Online Resources is JD Schomburg. JD is our Director of Business Development. He's been with Online Resources for the past 8 years and been involved with 3D data collection for the past 19 years. We also have in our film studio today, Mark Battisti. Mark is here with us from QPoint Robotics. Mark is not only the Director of Technology, but also the mastermind behind the development of QPoint's robot management platform. I want to say that correctly. He has worked with his team of developers for the past 12 years to create what he's here to show us today. Welcome, Mark, and thank you for being here with us.
Okay, thanks, Christy.
All right, JD, if you could just take a minute to introduce Online Resources and tell them a little bit about what we do here.
Sure, thanks, Christy. So I'm JD Schomburg with Online Resources, and we started about 30 years ago. Actually, this year was our 30th anniversary with a CAD/CAM product, and we quickly developed into a 3D technologies company. But our goal wasn't, so we picked up 3D printing, 3D scanning, inspection quality control, and reverse engineering. And our goal wasn't to push a certain product, but really to identify the winners in each segment and make sure that this 3D technology was simplified and easy to use. So with the Industry 4.0 movement, we decided to partner with Mark and QPoint Robotics, because we really see how they take the robotics side of things and simplify that and make it easy to use. So that's a little bit about us, where we were, and how we came to partner with Mark.
Great, thank you, JD. All right, Mark, well, hearing that, let's hear a little bit about QPoint and this company here, and before we jump into our showcase today.
Okay, great. So, the concepts that we're gonna see here today started quite a number of years ago. The early stages was a lot of automated testing, analog signals, sound and vibration analysis, weird stuff, analog signals and PID control. And then from there, progressed in my career to managing robotic automation. And for quite a few years did that in what I'll call the traditional sense, and what is still the pretty common way that people deploy robotics today, in the traditional sense of a PLC master and the control and the robot programming and all the kind of handshaking and tying that happens. Well, observing that and knowing what the past started from, it just seemed to me like, my gosh, there's so much more this robot can be doing than what we're letting it. We're treating the robot like an air cylinder. So that kind of started the development of these products. And so it's been going on for a long time in the back of the head, but in earnest for the past decade plus. And the products that we've got here show that. So our goal really is to make the robot easy. We're kind of a weird company because we look to some like a robot integrator, but really what we are is somebody that's created some tools that any integration company can use to make their robot, very, very effective and useful. And there's a lot of sophisticated devices that are coming on today. The 3D scanning we're going to look at today is one. And to integrate that in the traditional sense is cumbersome, just to put it simply. But with our tools and the way we've developed the apps, it all kind of comes together in a way that matches what our slogan is. We didn't make the robot, we made the robot easy. Similarly, we didn't make the 3D scanning, but we made the 3D scanning easy. And any real automation activity that a robot's doing. So that's kind of how we've grown over time to develop what we look forward to sharing with you here today.
Great, that's amazing. Thank you. So just make sure I clarify, you're taking very sophisticated devices, blending it together with any robot, and then, you know, without having to really learn any of the finite details of this, and it's going to work for its intended purpose. Today we're going to talk about that being inspection, but really for any intended purpose that you need it for.
That's right.
Wow.
That's right. So it's easy. I mean, you get a new phone and you have to learn how your new phone works, but kind of once you get the hang of it, you can do about anything with your phone, right? And so the same mindset applies here. There's a little bit of learning curve for some of it, but all of the hard stuff is taken care of.
Wow, very cool. Well, can you show us some stuff here?
Yeah, let's make it happen.
Great, thank you. All right, so you're going to talk us through what you're going to do here, right?
Yep, so we've got the screen shared there so you get a little bit better look at what's up here. So this is our platform here, and I'm just going to get this robot started. All of the apps that are on here run in a pretty common format. So get the system ready, everything's happy, I'm going to say go. So now this system's ready, looking for parts to run. We'll say, okay, there's one ready to go for you. And so what's happening now is the robot is scanning the part, all kinds of lasers and cameras looking at it with this cool device here. And you can see on the screen behind me a 3D representation of the part. And not just a representation, but that's actually calibrated measurements for this part. And so that's what dimensional scanning looks like with a robot held scanner. There's a variety of ways to do it, but when you look at this, it's like, okay, sure, it looks like a robot doing robot stuff. And it's exactly right. But how we got here is kind of what we wanted to talk about today. Some of the tools we use to make this easy, and the ownership side, once it's running, how to do more with it.
Wow, great.
So JD, looks like we got the scan taken care of there. I guess the next step in the process is to do the analysis of it. Okay, here we go.
So can you guys see my screen?
We can see it.
Looks good.
Awesome. So we had the scan forming die STL. We come into our PolyWorks report. This is a pre-setup report, very standard for PolyWorks, that we have automated the files or the STLs from the Creaform HandyScan Black Elite to just come in and automatically run a report. So it happened faster than I could switch my screen. So I have an additional format STL file that I'll show you and just manually replace it. But once this is done, it sends the yes, no signal. If we wanted to see what the report actually is for this in a PDF format, I can just tell it to export the PDF report. I'll save it as report 1. And this report will pop up with all of the dimensional checks. So we have our initial nominal model. We have the callouts that were needed for the part and whether those pass or fail. So we have the nominal measurements, the actual measurements, our tolerances, and the deviations. So for people who are familiar with the PolyWorks or just inspection systems, this is going to be pretty standard stuff for you. And so then we can go down, and we also have a full color map deviation, which green is good, and the red or orange is where the wear and tear might be happening, and you can see some blue here where some is probably the wear and tear on the die itself. And then we did a full GD&T surface profile call out, and we have again the same thing. So we are failing because of these low spots here where the wear and tear is. So that's pretty much the inspection process, how it works. So let me go ahead and show you what it does, what it looks like when it reruns. So if I just come up here, say replace, and I'll do an additional file here. and say, okay, rerun that file. It's going through and rerunning this, and we now have our new format, and we can go down, and this has already sent the pass-fail signals to the rest of the systems, or it saved the report in our server area where engineers could dig into this a little bit more and really analyze what's going on. So that is the Polyworks inspection side of things and how it's automated from the robot to the actual inspection software. And another thing is I'm off site right now. So this is showing how this data can be sent back and forth. As long as you guys are sharing this server and can connect to that, you can get to your data. So that's a pretty cool function and showing how it's working live here.
That's awesome. Thank you so much. Appreciate that.
Yeah, that was good, JD. So now that we've taken kind of a closer look at how that works, I mean, that's the way you have to do it, because when we're automating it, you don't see all of that magic happening. But that is part of what's called, as soon as the scan happens, then that report is generated and the data is available for whatever secondary processes need to know about it. So cool.
So we had talked a little bit before this, and we had talked about teaching tools.
Okay.
How we're going to do that. I would love to see you walk through that with everyone else. I'm sure they'd be very interested in how you get this robot to follow that path. And there are multiple different ways. So if you wouldn't mind sharing that with us, and I know there's maybe some fun stuff over on your table over there that you can show us, we'd appreciate it.
Toys is right. All right, let's see. So when it comes to, I guess, complex paths, this is an area that we really have fun with. I know that, you know, what we're looking at here, you can see this robot's blue. So we know that to be a Monoman arm. The yellow ones are FANUC. You got ABB, Mitsubishi, Denso, you know, KUKA, the works. Doesn't matter what robot it is, including the collaborative arms. You got the UR, TechMan, and the Abu. They got all kinds of different arms. Our system is compatible with those, and there's lots of advantages. With the industrial arm, you know, you can move it around with the teach pendant, of course. We all know how teach pendant works, or not all of us. People that are new to it, maybe this thing looks kind of confusing, and to most new people it is. But you can certainly jog the robot around with this. We also have this patented technology called RoboNav, and what happens is, not quite ready to do this live for you on this system, but nonetheless, if this was the robot, this clips on, has the same kind of safety device as you have on the teach pendant to make sure it's safe, but you can enable this and just drive the robot around. So that allows an industrial robot to be manually driven by hand, similar to how collaborative arms are. So sometimes, you know, as a human, you know what you want to do, but to try to know which X, Y, Z button to press to make the robot get there is kind of cumbersome. We take some of this stuff even a step further. This is a device we call the Magic Wand. We try to get a Q in all of our product names somehow or another, but this is a buggy. Toy making company makes these guys, but they need to do some trimming on it. So with this, what you can do is, this is calibrated to the robot's environment. You literally can just draw a path on here, and that's recorded, and that turns into a robot path. So for cutting processes, dispensing, different kinds of trimming applications, you know, a lot of that kind of 3D complicated path, it's real easy to just trace your part. And then you trace the part, now you've created a robot program that way. So the concept of teaching by suggestion or teaching by demonstration is what a lot of our stuff is built around. Taking that one step further, we can create tools, like this happens to be a magnetic gripper for sheet metal handling. So if you were to, as somebody driving with the teach pendant to tell the robot to go all over the place, it gets a little weird. If you ever operated a press brake, you have to flip the part over several times to make it. With this, I can hold this device in my hand. You can see the dots that are on here, they get tracked. We kind of set up a new tool, and we can go ahead and move this around as a human to show the operator what to do, or show the robot what to do. Go over here and pick up the part, save that. Go over here and set the part down, save that. After it's done, pick it up upside down and flip it over, save that. And so we can teach that motion, and now you can see there's a tool changer on here. We would then go ahead and clip that onto the robot, and now the robot's ready to do the same thing you just showed it how to do by hand. So those kinds of teaching concepts are all designed for speeding up the training of complex paths. These scanners, in a similar fashion, can do scanning by hand using my own hand, let the robot then take over and do the scanning. So in teaching motion, we've got a lot of things at our disposal, and they all work together. Looking at our system here, if I were to tell the robot to finish up, let's go take a break for a second. I could show all these moves that we teach, come into the moves page here, arm the robot. And so for the motion that we have here, through our software, as we're teaching all these different movements, we're building a map. Anybody that's programmed a robot before, you know you can go through and teach a bunch of points and write your program and it can work. The hardest part is what happens when something's wrong. Well, with this, we can just jog around from anywhere to anywhere. Let's say I want to go down into that scanning path, halfway into the middle. I just hit go, and it knows it has to come back to home, go into the entrance area, go through some of the scanning activity, down into the location. And then that's where I told it to go to. So sometimes the machine will stop and it'll crash and it gets in a weird spot. Cables are twisted up. How do you get it home? Well, with this, since we're building a map, you just hit go home. And it knows to follow that path backwards and get there. So this kind of escape routine stuff is something where we kind of take that motion and we just manage it in a much smarter way. You know, in your phone, you hit your little GPS and it gives you directions home. Shouldn't the robot do the same thing? That's what we got here. So and that's some of the teaching motion. Does that kind of help, Christy?
Absolutely. So I guess next question then would be, what if we have a different part? What if we need different parts, you know, with the same robot? Is that possible?
Of course. So we really enjoy the high changeover world, and since our tools make things easy to set up, being a high changeover type of a process is a lot of what we're geared towards. Of course, we can run the million parts a month kind of systems as well. So we'll take off this forming die and I don't know, let's throw something else. Here's a casting. So got that on there. So on the software now, we're able to go ahead up to the style editor, and we can pick a different style to run. Some people call this a recipe page, but go ahead and pick the casting now. Has a little bit different path on there. That's all loaded up. Update the system. It's now building a new map. It knows where everything is with the new motions. And we can go ahead and run this now. So if I request a sample part, you can go ahead and now run a different path. So you can see live on the screen back there, it's now scanning this new part. So that was just a little bit of goofy moving around, but you can see we got a pretty pure scan of the part. If I wanted to teach this and refine it, I would just come back in here and touch the item I'm interested in, the processing path. Oh, not in auto mode. I'm gonna finish up first. So it won't let me make changes in auto right now. There are some tweaks you can do. We'll talk about that another day. So now I can go ahead, since I'm not running the processing path. This is where it's neat, because when we teach movement, normally on the robot, you're just sticking a whole bunch of points in you know, 0.1, 0.7, 0.18. Then you have to edit the robot program to do them in order. Different robot controllers do them a little bit different. What we build is an action, and the apps have an action for that. And for this that you're seeing on the screen here, it represents how to get from home into the area of interest, and then do the action in that area, how to get out. With that action, there's certain permissions with that zone, and there's a certain tool that's attached to the robot for use in that zone. So those three things together, the permissions of the area, the hand on the robot, and the movements, those all work together in what we call an action. So you can go in and we can teach this action. So here I am, going to arm the robot. So I can walk right through each of the different locations. So it'd come out to the home position, and then you can just kind of step through. Okay, so here we go. So stepping through each of the motions, just by clicking the button, you can walk through the path. You can say, oh wait, that one's no good. I want to move that one. So all you can do is use any of these different teaching methods, dependent. We've even got some on-screen stuff. So I can say, I want to be a little bit closer down for that, and maybe a little farther over this way. So you can do some jogging on screen. And then I want to update the point. Read that, boom, it's stored, it's done. Save that. Update, and now it's ready to run that new motion. So there's other things we can do. I don't know how much you want me to get into. I could show teaching a whole like addition to a path.
I would love to see that. I
Okay.
think, yeah, I think this is a huge interest to everyone, because in the past it's been cumbersome to change a path. And you're telling us now that your solution offers an easy change to a pathway, or even to, you know, to a different part creation.
All right, so what I'll do is this. We'll go ahead and arm it. We're back into teaching, the same place. We'll step through. Here's the couple of points. Now I'm at the end. So let's say we want to do a little more emotion on here. I'm just gonna go up here, and this is kind of an easy way to do it. I can go ahead and just add points every time we change by a certain amount. So this is kind of a dynamic way to be teaching. So I can just now switch back into dependent control here, arm this guy up, and I can move around by hand, forward, up this way, and you can see points being added on the screen here as I'm moving it around. So it's just remembering exactly what I did. I could have been teaching this movement with the hand guidance, driving that around just the same way. And so as we add these points, another thing you can do is maybe you want to move to the next location you've got. And then you can just add that one point by itself after you got there. So just kind of building that action. And all of this movement is in the middle of our approach and exit to that, and it maintains all of that for you. Sometimes when you insert in a robot program, you went from P1, 2, 3, 4, 5, and you taught it, and you're like, oh, got to put one in the middle. But then you have to remember that point 17 is actually after point 2. It's just a mess. So with this, we're storing all the action and movements inside of here. So we've gone ahead and done that. We can save those changes. Now we'll go ahead and run it. So you can see it's down inside. The first thing it does is it calculates the correct way to get back home. So that's, again, some of that startup, auto startup stuff. It just knows how to get to a safe place to get things going. So here, we'll go ahead and run this path that we just edited. That should look a little different. So it's about here that we started adding. So you can see this is a lot of the dynamic points that we just threw on there. And now we got a little bit prettier picture back there. We did a little more scanning, but it's that easy. And that whole thing is now part of the escape routine, part of the robot's map, and everything.
All right. Very cool stuff. What else? Tell us more about this product.
Okay, so we've hit kind of hard a little bit some of the teaching process. Take a little bit of a step back and look at what we have here. So this cabinet here is one of our products. We call it the lean interface. It comes ready to run. So really, you get this and you add it to any brand robot and the world is open to you. So that's kind of the heart of all of our stuff. And then we have some other things we add on to that. So with this lean interface, inside of here, depending upon what brand robot it is, there's one little board, and that pops in and connects to your robot, and then now you're ready to go. And what we've done, on the back side, there's a variety of connectors. I'd spin this around, but it's heavy. On those connectors, you're able to then just plug in any inputs, outputs, safety devices, whatever you might need to connect, and it's all cabled into the back. So if you look at the safety app here, you know, if I were to hit an e-stop, then it recognizes that, it sees that, and the app manages it. All of the safety is just plug and play. Just plug the things in, it's ready to go. That includes machine tending applications where you've got, you know, maybe you have a human mode you want to run the machine manually, put it back into robot mode, the blended safety with a machine tool, all that stuff is covered. There's a safety controller inside of here, and that takes care of all the safety pre-set up. No engineering meetings, no discussions, it just works. And then there's plenty of room in there to add a little bit of extra stuff if you want it. So safety is taken care of. I/O from the robot is taken care of because we make the robot's I/O field I/O. You don't need any other controls hardware. You don't need the PLC. You don't need other stuff. You can have them, but you just don't need to waste the money or the engineering time to screw it. Another thing up here, there's a camera. This is kind of fun. So we call it the event recorder. You can see on the screen up there on mine, it's a live view of what's happening. So, hi, Christy. So if Christy were to go ahead and take her broom handle and jam it into the system while it's running, and then all of a sudden the system faults out, the system would say, "Oop, I just crashed. Give me that video." It goes back in time magically, creates a nice little video of the seconds leading up to when Christy made the machine stop. And then on our alarm page, instead of it being just a list of things, you can go ahead and you can look at you know, videos of all the different things that have happened and stoppages. So that's our event recorder. Stack light ties right in. Interface, what other kinds of good stuff? I don't know. There's a variety of different accessories, but then the scanning technology is another thing that ties in. So this app right here, right now it's got a static image on it. What it would be is a live view of the actual scanning process on a normal installed system. And so we kind of tie the different processes in a variety of ways. So some of the other apps that you're going to need for a full automatic system is how do parts come in and out of your cell. So we've got apps for, you know, feeding or tying to your production line, sending the results, statistics. Anyway, so if you wanted to add an app, whoops. You just go to setup, add an app, just like you know, any kind of app store, pick different types of robots, hand tools, feeding processes, whatever, and you can add those in and kind of expand the system. So the versatility is there, the plug and play nature. Anyway, we just have fun making these robots do cool stuff.
So I guess one of my questions is, how would this work in an inline scenario? Talk me through that.
Okay. So this is one of those situations where each system is going to be different, right? And this is where it becomes hard in the traditional sense to go ahead and run a system or figure out how to integrate it. What do I got to do? I got to talk to all kinds of people. That process requires a little bit of thought, but we've done a lot of variety of these. So you might have a continuous production line, you might have palletized systems, feed parts around, you might have manual stations. Whatever it is, we've got different things we could do. This happens to be a robot-held scanner, which means the part is stationary and you're scanning it. Pretty common. Something that's pretty cool, though, is to have a stationary scanner and a robot-held part. Imagine you already have a machine tending process. You're going into the machine tool, you're getting your part, you take it past the air knife to get some of the coolant off, and now the robot has this part in its hand. It can go ahead and present it to a scanning area, and you can get instant dimensional information of that part before you put it in the, you know, send it down the line or put it in the reject bin. So that's a way you can tie it directly to a process you already have. Or, you know, we can have the scanning robot and a handling robot work off of the same system. So we can do a site visit, we can help with that and look at the different, you know, layouts that would be appropriate for you. But I guess the thing to understand is the versatility of our system and the way that it interacts with the feeding modules. I mean, it's all kind of there. So if I get this into auto mode again, oh, safety. See, that was flashing. That's what it was. It just tells you, hey, this thing isn't ready.
I have to say, I love the safety features, because a rogue robot could be very dangerous.
That's right. So on this, we've got this app, and you can see on one of the monitoring pages that we have here, you can look at the handshaking, and this is where each of the different apps already has its rules defined for how it interacts with the process. If you were to zoom in on that guy and pop up its little information, this is all kind of standard handshaking stuff that every app works with. So it's a matter of, do you have a conveyor that's feeding parts? Do you have an index line? We have the app for that. You can just live select and you assign the signals, it pops them up, things flash, you pick the thing that's, you know, the right sensor, boom, it's assigned, and now it knows what to do with that signal. All the, you know, monitoring, diagnostics, and management is, it's all in English at that point.
Wow, very cool. So you're going to start it back up again here. We're going to watch another scan.
I think so.
Well, while you're getting that set up, let me ask JD a question. JD, we've worked with QPoint for quite some time now. Can you talk everybody through what this process, how you even begin this process? If you wanted to integrate something like this into your manufacturing process, what would be the steps you would follow?
Sure, and that's a good question, because it can be a little overwhelming. So I'm going to speak mostly from the AQC side of things, or the automated quality control, where we're using 3D scanning systems with the GD&T side. The process might look a little differently for some of the other applications that Mark does. this is just what I'm most familiar with. But really, we start with justifying the need. So what are we trying to accomplish? Cycle time things, the different challenges that might arise. So once that's been established, then we'll identify the correct end-of-arm tool for the job. So in this case, and a lot of times we find that the Creaform systems, the HandyScan Black Elite or the MetroScan Black robotic version, really accomplish 90% of the things. So, but we still want to make sure that that tool, that 3D data collection tool, is going to accomplish what we want. And then we need to go and make sure that the GD&T or the software side of things is going to accomplish the same tool. So we go through a justification, end-of-arm tool requirements, and make sure that can do the job, the software, and then we can bring it together and work with the customer on exactly logistics at that point. How do we put it in? When do we put it in? Things like that. And then once we kind of get all of that put together, we start moving forward with the actual action items from the project manager side of things. So that's a pretty high level. I hope that helps kind of break down how this process works.
Great, thank you. Are you all ready for us, Mark?
Yeah, so what else do we want to see?
I think everybody probably just like to see your scan again one more time at least.
All right.
Let's watch this work. And this is the new one with the additional points that you created in it. So we've remembered that, and there's no question that just became the new normal.
That's correct. Yeah, and when you start up again, power outage, whatever, it remembers wherever you were at and whatever you were running last, it's ready to go. So
Awesome.
yeah, so that's kind of it. And on this side, we can go ahead and look at the scan if we wanted to a little closer, and some of the stuff that JD showed. But really, I think this is fun to look at. I think it's super cool how you can just whiz this thing around like a can of spray paint and get this kind of accuracy of measurement.
So I guess for me, my next question, my next thought process would be, what does this kind of a system cost?
Good question. So I mentioned earlier that, the lean interface plus the robot is kind of the starting point. The rest of it is mechanics, and there's always going to be some unique maybe tooling that you have to build for given applications. Robots, they are kind of like cars. You can get one that'll get you somewhere for 20 grand, or you can get a nice fancy big heavy truck to do all kinds of stuff for 70 grand. Robots are about the same kind of numbers price wise. Our lean interface cabinet is 18 grand. And with that, it has all of the apps available to you. We do have some authorized people, or we can help you to create some new apps. Maybe there's some special processes. It's very easy for us to add things and expand that for special needs. But that's kind of the starting point. So funny story with that. One of the customers we're pursuing, I say, hey, how's things going? Just wanted to see if you made a decision yet on the project. And they said, oh, we threw your quote in the trash. I was like, what? What'd you do that for? He's like, well, that was too low. There's no way you can do it for that. I was like, oh, all right. Well, I can add some money to it, or you can give us a shot. And anyway, it turns out that one worked out real well. He got the system done, less than he thought he'd be able to do it to. And really, the user experience, was there for him much more than they want. Speaking of user experience, support. I don't know, we didn't really mention support.
We have not yet.
This is something that's fun. Here's, phone. I could be in another, or any of our techs can be another part of the world for you. And, you can see the system over there. We can make those same changes I was making on screen from remote. So for example, if I wanted to run that system again, we just go ahead and poke a couple buttons on here, and oh, look, the robot's moving. And so the ability to see that event recorder camera from here, or not just a phone, but from a desktop somewhere else, make changes. This is the kind of support we really actually enjoy doing it. People call, hey, something ain't quite right. Can you take a look with us? Sure. We jump right in. And oh, you might want to look at your sensor on your end of arm tooling. It looks like it's flaking out a little bit. You can go in, disable it. The system will keep on running. They get it fixed, up, switch it back on again, and you know, that's another cool thing with the apps and the support.
So this is something that, let's say, a technician or an engineer who's on the floor running this, they can walk away with their phone and have the same capabilities if they were standing right there next to it.
Yeah, there are certain credentials if you're going to be able to do it from actually remote. There is a functionality where you can have a local view that you can walk around with. So you can go up to the screen and say, hey, put it on my phone. And so you can maybe crawl underneath somewhere and have full access to the screen. So it's sort of like on the robot, you grab the teach pendant and you tug it around, and then all of a sudden the cord stops, right? You know, and you can't get there or whatever. So with this, you just kind of, everybody has a phone. Everything's on the phone. Everybody does everything with their phone. Let's make our robot systems work on the phone too, I guess.
And that's just an app, so that could go on pretty much any smartphone.
Yeah, basically you would just kind of scan the screen in that mode, and then it goes ahead and projects it to that. Little install, but yeah.
Wow, very cool.
Yep.
Very, very cool. Well, I guess before we kind of finish up on this side of things and jump into questions, is there anything you want to say before we, you know, kind of close this side of things out, the showcase out? Anything you want to add to this, or make sure that everybody understands or knows about your product?
Man, that works, I guess. That'd be one thing. Yeah, we've installed quite a number of systems, quite a number of brands of robots, and you know, there's like we said when we started, it looks like a robot doing robot stuff, right? When it's running, nobody cares how you got there. But it's when it's not running, or when you're trying to get something new taught or set up, that's when things matter. And with the higher changeover, a higher part variety world, those things matter. And so I guess that's the biggest thing. Yeah, there's a million ways to automate a process, and you have the ability to choose how much you want to enjoy owning it. And so I guess that's where we come in, is the ownership and the value experience. So lower cost with more capability, and I don't know, I guess the other thing to take away, new engineers, I love them, but all they know is to play on their Xbox or, you know, use their phone. And so it's one of those can't beat them, join them things. You could teach them the old way people have been, you know, doing robots for many years with PLCs and the programming and the hardwired stuff and the handshaking. Or you can show them this and they just kind of say, well, yeah, it makes sense. Isn't that the way it ought to be done? Well, yeah, we think so too. But in the past, it hasn't. So as the newer breed of people are coming out, the things that they're familiar with, this just connects with them. And so I think that's a big thing to
Definitely a value add right there.
Yeah.
Yeah, great, awesome, thank you so much. Okay, so I think we're at the point where I'm ready to turn the time over to JD. I'm sure we have some questions out there that we can ask and that people have asked, and let's talk about that.
Cool. So we do have a couple of questions. See, one was, I think you talked about it, the app base, and they're just kind of saying, does that require an engineer to use that? It sounds like just maybe give a little bit more about the benefits of the app-based system.
Okay, so with the user interface that I was poking on over there, there's a lot of standard functions that are on there. There's lots of buttons, lots of things on the side. It's all common across each of the apps. So when you have one function that you're used to, and then you have to go investigate something else that's on the machine, you look at it all in the same way. So for each app, you can look at the status of it. Everything is presented in English words. So when you're looking at it, you don't have to know, oh, I think that's input N7:4/3. Go ahead and find the wire that has those jumbled letters on it, and then I think that's the one we need to play with. No, the app is going to light up for you. It says, I'm the one that's having the problem. You then look at it and it says, hey, my grip closed sensor is needed to be able to move forward. And you go, oh, I bet you we should look at the grip closed sensor. Yeah, maybe. So it's that kind of stuff where, you know, we have put the stuff on the surface to draw to people's attention so that any guy can walk up and understand it. Are there things behind the scenes you can get into? Of course. For the scanning application, there's some pretty interesting things in the background that you set up. There's a scan configuration file where you would teach the background and the standard clipping planes of the scanner. So at a little more of an engineer level, you would set that stuff up in VX Elements, which is what the scanners work off of. You would save that, but then when it runs, all you have to do is call up that file and it works. Similarly, in PolyWorks, the engineer would have to know what GD&T means and then go ahead and use that report to, you know, say what PolyWorks is looking for. But then it's just a matter of, hey, identify or name the PolyWorks report in the settings or on a part-to-part basis in the style, and it'll work. So there are login permissions if you need it, but yeah, it's all just kind of tied together that way. So hopefully that answered whoever asked that out there.
I think so. It actually clarified some stuff to me and why I'm able to understand the robotic stuff a little bit more. Because you make it pretty upfront and easy to understand. This is my question. There are a few other questions, but how long in general is the learning curve for this kind of system?
Great question. Most of the systems that we install, we offer some formal training, which is like, you know, sit somewhere and do something about standard stuff, but it seems like that's never necessary. What happens is when we're installing it, like, hey, come here, Dave, let me show you. And we just kind of stand next to it, let's run it, show them some of the standard ways to look for stuff. And, you know, so most of the training happens at the conclusion of the install process. We just kind of work together for a handful of hours. And, you know, once you see how to look for things from one app, you can see it for all of them. I didn't talk about all the different buttons on there, but you say get ready and all the apps report back, hey, thumbs up, I'm ready, or they say, whoa, I need some help, and they flash, and you say, oh, okay, I got to give that one a tick. Well, you saw when we didn't have the safety right. Yeah, so it said safety's not ready. So say get ready. If the go button appears, boom, hit go, you're in auto mode and everything's happening. You don't have to teach them, remember, jog the robot with the teach pendant back to the safe place before you hit go. Otherwise, when you hit start, then the robot's going to swing around and hit through a building column and cost 60 grand. So since we have a lot of that motion management, the escape routines built in, the need for the training for, oh my gosh, don't break your stuff is much less required.
So to sum that up, it's almost like on the operational sign off, you're training everybody. So as they're approving the system for functionality, they're getting trained.
That's right. That's right. And that's operators is who we mainly focus on, and the job setters or the managers of the area, they, you know, kind of look over the shoulder but it's the operators that have the understanding, and they think it's pretty fun, to be honest with you, because it's not like, oh, I'm just an operator, I can't do that. It's like, holy cow, man, I was just a manual operator, but now I'm gonna go home and tell my wife I'm running a robot now, and it's cool, you know, it's fun. And anyway, so most of the operators tend to, you know, think it's pretty neat. And you know, when you have this robot that's picking up 500-pound sheets of glass and slinging them all over the place, and I mean, you can cost, you know, a lot of money doing the wrong thing, but they're up there just poke button, hey, go here, 100 miles an hour, do it. Like, that's me, I'm running a robot now. So it's kind of fun to sit back and watch them do that after, you know, an hour's worth of training.
Cool. And so next question here, they're asking about the robot. What robot are you using today?
This one is a Motoman or Yaskawa arm. Okay. You know, we tie together great with those. There's plenty of brands that we work well with. On our site, you can see a lot of videos. There's plenty of color robots. And there's also some pricing configurators. Back to your pricing question. If you go on our site, you can hit build my system. It's not a formal quote, but it gives you a rough idea. Hey, this is what I'm trying to accomplish. And you can get a pretty rough, you know, pricing on what a system would be. And I think you'll be pleased with what you see.
So just for everybody really quickly, would you mind sharing your website address so that anybody on here would have that?
It's Q, the letter Q, point, P-O-I-N-T, robotic, robotic.com. So I can pull up on the screen. I think we'll probably send a little something to everybody that was on here. But yeah, QPointRobotic.com. And anyway, so yeah, but Motoman, Fanuc, ABB, Denso, Mitsubishi, Universal Robot. I mean, you name one. And there's also plenty of non-official robots. Like you can build a 3-axis system, IAI and SMC, and a variety of players got some little motion packages. We work with a lot of those. So. And the newer protocols, you got like IO Link and other devices that are out there. Of course, we tie in all of those protocols as well for some other devices.
Cool. And then we're kind of on the quoting. I'm going to try and get on that website as we're talking. I sent out in the chat, you'll see the actual website. But you want to maybe dive a little bit more into pricing and how that may work. I know with inline it kind of grows, but what's like the starting point price systems for this?
Well, we've got some pretty nice standard packages. I think on the screen you're showing right there, the third one down is pretty cool, and you know, just under 100 grand. You can slap this guy alongside any indexing line and be getting dimensional measurements for every part. So, you know, depending on the cycle time that that you're indexing at, but you know, that's a system. Down the bottom of the screen is a little bit fancier system using the MetraScan technology. That one starts to push 300, you know, between the robot, the integration content, and the scanner itself. But that's for very large part volumes. That one's neat. That's just fun. So you can measure something that, you know, is a couple meters away with super accuracy without ever touching anything or no fixturing, nothing. You just kind of pointing this little magic disco ball on one side, pointing it at the other, and you get this whole map of the surface. So, but we do a lot of systems for machine tending, automated inspection that are in the 80 to 150 range, which an ROI for a 1 or 2 shift operation is usually pretty cake to justify.
Very cool. You want to talk us through what JD's looking at here?
Yeah.
So that's our, if you go up to the top where it says system kits, or robot kits, yeah. then, you know, so like you click on machine tending there, and it has a little configurator. You scroll down a little bit where it says price and build. Yep, so now you can just answer a few simple questions so you get started. And so are you, working off of a machining center? You just kind of click and add, and then it gives you a pretty rough order of magnitude on what a system will cost you as you punch through this. And it'll send an email to us when you're done, and we'd be glad to interact with you and help.
Cool.
I'm assuming you get this email too, or you get this interest, and probably the first thing that happens is an on-site visit.
I mean, yeah, our sales team will take a look at it. They might ask you a few questions. Sometimes people click the button and say, I have 100 different parts. So then they pick the quantity 100 for some of these things. And the quote says, a really big number. And it's fun to call them and say, hey, got your, inquiry there. It's actually giving it a ton less, because I think you don't really mean you need 100 of those bowl feeders. You just have, anyway, so. But yeah, we'll talk to you, have a quick discussion. We can refine maybe the budgetary a little bit. And yeah, we're glad to schedule site visits to help people evaluate or figure out what the next step would be.
Cool. So I'm just playing here on the website, and so it's pretty easy, just answering those questions with the graphics, and then you get to add, and you have a quick budget number. So I'm going to copy this website and send it out to the chat again for everybody, so they can get there quickly.
Awesome. Thank you. Thanks for pulling that up for us. That's wonderful. What a cool tool to have.
Yeah, not every version of every system is, active on that, but, it keeps growing with the different versatility.
Cool. So we do have a couple other small questions that are pretty specific. That's why I wanted to go through this cost estimator. It seems like they all kind of lead back to that. So we will get in contact with each of you guys on some of those specific questions, or if this cost estimator kind of answered those for you, we'll probably still drop you a link and say, hey. So, but that's all the questions I see right now.
Great, okay. Thank you. Well, Mark, I just wanted to say thank you for joining us today. We really appreciate your time and bringing in the robot to our studio and really sharing all of this information and knowledge with us today. So thank you very much for being here.
You bet. Yeah, I really value the relationship with Online Resources. Great character of people and fun technology too.
Yeah, it really is. It's a really fun one. I really like this. Thank you all for joining us today for the deeper dive webinar with QPoint. We appreciate your time and hopefully you learned some stuff. If your question did not get answered, we will get in touch with you. One of our engineers will get in touch with you to discuss that in further detail. This innovation with robotics and scanning are transforming manufacturing and that marketplace. So I hope that those of you who did have the opportunity to be here today now have a starting point for integrating these processes into their environment. As always, if you have additional questions or needs, you can call us anytime. Our number is 765-482-9700, or you can contact us via email. That's at support@onlineresourcesinc.com. Thank you all again and have a great afternoon.